Hello, everyone. Today, we would like to share our story and how we modernized our data collection using Amazon DocumentDB. So we're going to start like an introduction about FINRA, what FINRA is, what we do, and an overview about data collection platform. And in addition to that, we're going to cover also how FINRA benefits from Amazon DocumentDB. So FINRA stands for Financial Industry Regulatory Authority. Our mission is to protect investors and market integrity. So we detect any bad activities in the market and also make sure that all the participants and parties involved in the market transactions are following the disciplines that SEC and FINRA puts together, and also take any actions required to make sure that we enforce the rules that we put together. So FINRA named like number 1 best place to work in IT for the mid-size companies in our 10th appearance in the annual list. So our mission also like protecting investors. So we regulate about 99% of the equities events in the United States stock market. And we regulate the brokerage firms that participate in the transactions, and all the broker dealers that work for this securities firms. So we regulate about 3,700 brokerage firms and 630,000 broker dealers or investor advisors that they work for these firms to make sure that there is no insider traders, no fraud or any bad activities happens in the market. So some facts to share about FINRA. So we collect data from various sources. One of the main sources, or pretty much every single transaction that happens in the stock market, we collect this data. We get this data from 24 exchanges like NYC, NASDAQ, CIPO, and all of these exchanges. So we process up to 550 billion records a day, and it's one single copy of the data that we collect. And this number might have changed as we speak now based on the market volatility. So we get this data, we process it, and in order to process this data, we spin up to 150,000 nodes to process and get this data. So this leads to about 110 petabytes of storage, and the storage for this data actually is S3. So high level, again, I could not fit every single service that we use in one slide, but these are the main ones that we use in order to process this large volume, which is really big data. So our main service that we have here is HERD. HERD is an open source platform that FINRA built. And it is pretty much our data catalog that takes care of cataloging all the data that we collect from our data providers and make it available for downstream consumers and like just have like metadata about these objects, this data, and make it useful for internal use. So it's like a Java application running on an ECS stack, and the database is a raw database that has all the metadata information about the objects that we collect. And from an integration standpoint, when a data object or data that we receive from our exchanges, we publish an event for downstream consumers using SNS. So like we heavily use EMR for compute and also analytics. For small jobs, we leverage Lambda when we know that, okay, this process or this data that we are getting is going to take less than 15 minutes to process. We use Lambda for this use case. So from a storage standpoint, mainly for the market transactions, we use S3. And also, like we use DocumentDB for other set of data that we collect from our providers as well. And I will cover what are the different data feeds or data sets that we collect from the data providers. So some facts around like the data collection, as I mentioned, we collect data from like exchanges, brokerage firms, service providers that they get hired by brokerage firm to submit data on their behalf. So we have about 500,000 users that they use this platform on a daily basis. And this 500,000 users actually represent 45,000 organizations. So that this like the brokerage firms, like the 24 exchanges, other data providers, other entities as well. So we have 110 unique filing or form types. And to simplify, what does it mean with filing? Like when we do our tax returns, we submit, we need to fill in like 1040 form or different types of forms. So at FINRA, we have about 110 distinct filing types or forms that we collect from our brokerage firms or our data providers, with a total of 3.7 million filings that we collected, and this number is actually like the volume that we collected on 2021. So I'm gonna cover like a quick overview about 3 of different filing types. So the two, in order to get hired by like a brokerage firm, the brokerage firm needs to submit this filing information to FINRA. So we have 2 filing types, U4 and U5. U4 is more like the onboarding form. So for a new hire or transfer or change to the individual information, they need to submit a U4 form. And when the individual gets terminated from the industry, the firm needs to submit a U5 filing within 30 days of the termination date. So looking at these filings or this form, like U4 has about 15 sections. So you talk about like the personal information, like history information, like residential history, employment history, the qualifications required for these positions, or the positions required like to fulfill the positions requested by this firm for this broker dealer. Disclosures. So we collect this all of this information, and some of this information also contains like sensitive information like social security number, date of birth, and maybe some fingerprinting information. So we have 15 sections, and that represents all the different fields that we collect. And the number of fields in the U4 form is about 1,100 unique attributes in this form, with the nested structure. Like you have like I would say like up to 7 level depth from a hierarchy standpoint. Same thing also for U5, but the number of attributes is a little bit less. So having like 1,100 attribute for one filing, like imagine if you want to build like a relational database to persist this data and collect this data, how many tables we should use in order to store this information. So another facts about the volume of how many filings that we have only for U4. So since inception, when this program started like in 1990s, we collected 30 million U4 filings as we speak, and also like 2 million out of the 30 millions are stored in DocumentDB. For U5, the volume is a little bit less, so I have about 7 million filings, 200K only stored in DocumentDB, because we released U4 in October of 2020 in the new platform, and for U5, it was mid-year last year. So now, when we decide to build a new platform to collect this data, this is like the requirements that we put at front of us in order to come up with like a solution. So data security, as I mentioned, we collect this data, and some of this data has like sensitive information. Data versioning, we need to keep track of like the version of the filing. So an example here is, let's say like a brokerage firm submitted a U4 filing for a new hire, but after review, FINRA found out they need to submit an additional information, or they need to make a change to this filing. So they need to submit it as a new version. So we need to keep track of the versions and the changes of the filings. History and lineage, again, it's important to make it like when the representative gets hired by the firm, we need to know how we can tell the story, what did they submit, what are the decisions that were made for this particular filing. Schema versioning, so for any filings or any form, the industry might require making a change, adding an attribute, or retiring an attribute in the form. So we need to make sure that we're flexible enough to adapt to the industry needs as well. In addition to audit, who submitted this, what are the different actions that they could perform in this form. So we'll cover this as well. And in addition to that, record management, like each organization has like record management policy. Some records needs to be retained for 5 years or 7 years based on the business requirements. Now, looking again at the U4 form and the U5 form, we talked about 1,100 or about 2,000 unique attributes, and some of them also like arrays where we need to collect more than one entry for the same set of fields. So, looking at like a traditional database, I really want to see like how many tables we should use in order to support or collect this data. If we're going to go with like a table columns based structure. So in the legacy application, actually, we have between like 30 to 40 tables that we built in order to collect these fields in the legacy platform. So relational database, it's good, but it's not for this use case. So both when you use DocumentDB, it take advantage of like JSON as a data structure. So we really don't need to worry about columns and table and relationship between these different tables. So another advantage that we see also on the DocumentDB about like change streams. So we need to react when the data changes in the document itself. So in traditional like relational database, you build like a trigger, and this trigger will pretty much have like complex logic to notify or publish an event to like an SNS or any other service. So in DocumentDB, we can take advantage of like the change stream events. So looking at also the query in order to, we collect this data, but we still need to do analyze, like to perform analysis on this data by writing queries. And if we're gonna do joins only within this 30 or 40 tables, you can imagine how complex the query will look like. In DocumentDB, we take advantage of like the query, multiple fields, and everything in one single document and JSON structure. So what we have learned also in the design of this platform, like model-based, model-driven development, where we start with our model, and this is pretty much what the users and our customers will interact with. So when we talk about a form or a filing, it represents the schema, and the schema is like a JSON object or like an XML schema that it's published, so that they need to follow the rules in this schema. So if we're going to do this in a relational database, so this means we need to have a translation layer between this schema and our relational database model. And with the complexity of the number of tables and fields, this means we need to have like a dedicated DBA to maintain and build any changes required for this one. But in the DocumentDB, this is more like we take advantage of cross-function engineer who can build this data model. And this was also like we introduced the concept of a data modeler. So to build like a model that can be used for our back-end storage, DocumentDB, and also our API schema as well. So this platform, or this, it's not only built for U4 and U5. As I mentioned, we are gonna migrate like 110 different filings into this platform. So if we talk about U4 and U5 has like 30 to 40 tables, so do the math, multiply this by the number of filings, we might end up having thousands of tables if we wanna go with relational database. So this is like a high-level architecture view of our data collection platform. So we collect data from like various providers, as mentioned earlier. So the data comes either like data feeds or files. So the channel for the file submission is FileX. So FileX is another product that FINRA built in 2018, and this also like another great story to share between that showed a good example of collaboration between FINRA and AWS, and it's actually we're using Amazon transfer family to support like the SFTP interface. So as a data provider, I can choose either to submit data to FINRA through SFTP, S3 Direct, using CLI commands, or HTTPS. But this is the file-based submission. The other channel is filings or form. So we need to have like a UI where like an interactive form where the users can fill in the form and submit it to FINRA. So our data collection platform has like two channels also, the machine-to-machine for API-based submission, or interactive user where they go to like a screen where they fill in these filings. So now for the data collection, we have our backend service that it's a like Spring Boot application running on a Fargate, and the scope of the service is like being able to create or initiate an instance of a filing, and then like go through the life cycle of the filing by like creating a new filing, saving drafts, and at the end is submitting filing. So now we collected this data, and all the data is being stored in Amazon DocumentDB database, and we also publish events for our downstream consumers. And from high level, we just have two categories of events. One event that takes care of data changes. When there is a data change, we publish an event so our downstream consumers can act on this one. So as you see on like the instance change, like two use cases here. One is the record management process that takes this event and gets the data that's submitted by the data provider and copies it to S3 and register it with our data manager or herd that to keep it for the record purposes. In addition to that, other downstream consumers like the business application that they analyze the U4 and U5, they listen to an event for the U4 and U5 changes, and they take this event and perform their operations using SNS and SQS integration. And then they have their workflow implemented there. In addition to that, our sensitive field get or view, where we publish events to the audit services to make sure that, when someone clicked on a view SSN or view date of birth, it's being tracked as well. So we worked also with DocumentDB team to introduce a concept of data versioning. So if you remember, one of the requirements is about data versioning, where we need to keep track of every single change that happens to the data. So we introduced the concept of N+1 document, and actually N represents every single change event that happens to this data is being tracked in the N store, and 1 is the latest and the greatest version of the document. So having a new filing that gets submitted to FINRA, the first time this filing this gets created, 2 documents will be inserted. The first one will be inserted in the main collection, and another one will be inserted in the history collection. So this means we will have N+1 documents, and actually in the history documents, you treat this as more like an always insert, no updates. So it's an immutable collection to keep track of every single data that we have received. Now, when FINRA actually started using DocumentDB, we started using DocumentDB 3.6 6. And at that time, actually, like asset transaction was like work on progress, and DocumentDB team worked with us and changed the priorities and make sure that they have this feature implemented, and they introduced it in like Amazon DocumentDB 4.0. And this was like I would say an important feature that helped us to achieve one of the main requirements around data versioning and history. So some statistics around like the number of filings that we collected so far in DocumentDB. So we have 2.5 million documents or filings that we have collected so far. And in the history documents, we have like 12 million documents. Like math-wise, on average, we have like 5 versions of each filing. But some of them might be like only one version, some of them will be like tens of versions and so on. The average document size here is like 14.2 for the main filings collection, and 3.3 kilobyte for the history ones. So we also have the concept of, I mentioned about the different filing types, how DocumentDB or our data collection platform actually handle the different filing types. So each filing type has a schema registered in like another collection called like a template or schema collection that represents actually the data schema that it's used to for each filing. So an example here, like part of the process is we create a schema for U4 that mimics pretty much the schema and the fields and element that we collect. So it's a registered document in this collection. So I have like 6 filings so far running on the new data collection platform, and the history and the changes of the schemas actually are like 31. So again, like 5 versions of each document as well. Okay, so I shared like an overview about the importance of the data that we collect. I shared an overview about the requirements. We shared an overview about our architecture and some numbers about what we collected so far in DocumentDB. So now we would like to share also the benefits that we get out of it, and did we meet the requirements? Did we achieve what we were looking for or not? So now the one thing about DocumentDB, it's a fully managed service, and there is like a quote from Ranga Rajagopal, who shared this in 2019, that because DocumentDB is a fully managed service, our database are scalable, highly available, backed up, and encrypted without any overhead from our engineering team. So it's pretty much taking care of all the plumbing work for us. We really don't need to spend time on how we want to handle this or handle that. And it also simplifies this from an operational aspects and reduces the overhead from the operational engineers as well. So that's one of the benefits. In addition to security, I mentioned security is one of the requirements that we need to make sure it is in our platform. So Amazon DocumentDB is built to be enterprise ready, and it supports like encryption at rest using AWS key management service. With ability also to have like customer managed key as well, and also encryption at transit using transport layer security. So that takes care of the security for us, and this is again the plumbing work that's being done, and to take this out of the box by using DocumentDB. I mentioned about like the sensitive fields that we collect, like such as like social security number and date of birth. So FINRA actually implemented our own field level encryption, where we leverage another service also like Amazon KMS and Amazon encryption SDK. So we can take care of encrypting like any sensitive fields that we collect as well. And we work closely with Amazon key management service to make sure that we like the service gives us what we need when it comes to the field level encryption. So audit and history, I covered the concept of N+1, where we take advantage of having 2 documents to track every single change. Imagine if we do this in a relational database. I think the number of tables will be at least double, and it will add the complexity about retrieving this data later. So in addition to that, like over 50% cost saving on our AWS resources, and also better performance. So when like Amazon introduced like a new instance type like Graviton, so when we did like the cluster resizing exercise, we found out that the Graviton will give us over 50% month-to-month cost saving, and also like better performance. So we used less number of instances, and we get higher performance with less cost. Now, faster time to market, like as I mentioned, I'm gonna share like 3 different filing types, U4 and U5. One of the mechanisms that our customers submits complaints about their investment journey is called investor complaint form. It's an anonymous form that it's available for any investor to submit. So it took 4 weeks to build this form in the new platform. And the reason for that is we already have all the backend services working, and that's most of the time we spent is building just a simple schema, register it in the template collection, and making it available for our consumers. And also, we take advantage of like the natural JSON structure. It makes it easy for our downstream consumers to consume data in JSON format. So the benefits we get also is not only from like technology standpoint, our customers, like the customers that use our forms and submits data to FINRA. So these are like the benefits that they get, like significant efficiency gains, that like some of them, like they share that the time got reduced by 99% when they moved to the new platform and the new form that we built using the new data collection platform. And most of the time now we don't need to worry about, as I mentioned, the plumbing work. So we focus more on our customer experience. So we spend more on building more user-friendly and mobile-friendly UI to help our customers to submit their data as well. We built also consistency and make it easy, the interaction between the brokerage firm and the broker-dealers as well. So we simplified the workflow for this flow as well. So now that's the journey about like data collection. We use also DocumentDB for other use cases. So this is like, we have 3 programs that we just launched recently. Like FINRA implemented the CE requirements for investor advisor on behalf of North American Securities Administrative Association. So where we collect and maintain the CE requirements for investor advisors, and also maintaining qualification program. It's a new program that FINRA released in March to give the broker dealers the opportunity to take longer break from the industry if they qualified for this program. And we're transforming the broker dealer continuing education requirements as well. So we use DocumentDB to store this data. So we have about 1 million documents stored so far in the new DocumentDB instance, and this also includes the history as well. So this is our reference architecture for any domain service when it comes to like data or a domain that we need to start persisting. So there are 5 components, like the one on the right and left, like upstream and downstream. So this is more like event-driven architecture. So when an event that it's published by upstream, we kick off our orchestration service, and then we, based on the use case, either like persist the data in DocumentDB and then publish events for our downstream consumers. The key highlight here is we decoupled our business rules. All the business rules are included in the evaluation service, and the domain service is just like a simple create, retrieve, and update operations that makes it transparent and clear for downstream consumers. Okay, so this slide actually is not for me, it's for everybody in this room. to show like the history book is still open, and your use cases are welcome to be added to the history book. Thank you.